How's going on everyone? Welcome back to another video in data structure series. In our last video we have seen how we can implement singly linked list in C and C++ using structures and classes. In this video we will learn how we can implement doubly linked list in C and C++. The program for doubly linked list is going to be quite similar to the program which we have written for singly linked list. So similar to the program for singly linked list, in this program also, we will ask the user to enter the number of elements which he wants to store in the linked list. And we will store that number in the variable n. Then we will ask the user to enter the elements which he wants to store in the linked list. And to scan those elements, we will use a for loop which runs n times. And each time the user enters a number, the number is stored in the variable x. Then this variable is passed into the createList function. This function is used to add the elements in the linked list. Now once we have created our linked list, we will print out the linked list using this printlist function. As doubly linked list also store the address of the previous nodes, so we can traverse doubly linked list in reverse direction also. So this time we also print our doubly linked list in reverse direction using this backward list function. Now let us understand our program from beginning. So first we have declared the node structure. This node structure will be used to create the nodes of the linked list. As each node of the doubly linked list has three parts. The first part is where we store the address of the previous node. So here also we have created a pointer called priv. This pointer is of struct node type, and in this pointer we store the address of the previous node. The second part of the node is where we store the data. So here we have created a variable called key. In this we will store the data entered by the user. The third part of the node is where we store the address of the next node. So in this structure also we have created another pointer called next. And this pointer is again of struct node type, and in this we will store the address of the next node. Now once we have created the node structure, we create a pointer called head. This pointer is again of struct node type, and in this we will store the address of the head node of the linked list. But as for now we do not have any address that can be stored here. So we store null in the head pointer. Now let us understand the createList function. This createList function is used to add the elements entered by the user in the linked list. To create a node, first some memory has to be allocated to it, and to allocate some memory, we use the malloc function. In this malloc function, we pass the size of the struct node. This malloc function returns the address of the memory allocated for the new node, and we store that address in a pointer called new node. This pointer is again of struct node type. Now we have allocated the memory for the new node. After this, we store the data in the new node. As we do not have any address that can be stored in the new node, so we store null in both the previous part and the next part. And we store the data entered by the user in the key part of the node. We have also created another pointer of struct node type. This pointer is called the current node. And initially we have stored the address of the head node in this pointer. We will use this pointer to traverse through the linked list. Now once we have created the new node, it's time to add that new node in the linked list. And to add that new node, we first check that if head is equals to null. If this condition returns true, then it means that there is no head node and the linked list is empty. So first we have to create the head node. To create the head node, we simply store the address of the new node which we have created in the head pointer. And after this we return, which means that the remaining code in this function will not be executed. Now we have created the head node. Now when the user enters the second element, again some memory is allocated to it, and we store the data in the key part of the new node. Again we have to add that new node in the linked list. So again we check if head is equals to null. But this time this condition returns false because we have already created a head node. So we move to the while loop. We will use this while loop to traverse through the linked list. Now for the detailed explanation of how we are traversing through the linked list, check out our last video. In our last video, we have explained how we will traverse through the linked list. So using this while loop, we traverse to the last node of the linked list and we store the address of the last node in the current node pointer. Now, we store the address of the new node which we have created in the next pointer of the current node, which means that the new node which we have created has become the new last node of the linked list. Once the new node is added in the linked list, we store the address of the former last node in the previous pointer of the new node. Now the previous pointer of the new node points towards the former last node of the linked list. Using this createList function, we can add as many nodes as we want in the linked list. Now let's see how we can print the linked list using this printlist function. This printlist function is same as a printlist function which we have created for the single linked list. Here also we have declared a pointer called current node in which the address of the head node is stored, and this pointer will be used to traverse through the linked list. So we traverse through the linked list using this while loop. This while loop runs until the current node is equals to null. Each time we reach a node, we print out the data stored in that node and we move to the next node. When we reach the last node, we print out the data in that last node and the address of the next node is stored back in the current node. That is, null is stored back to the current node. So this condition returns false in that case and while loop terminates. So this is how we print the linked list in forward direction. Let's see the backward list function, because after all, this is the beauty of the doubly linked list, that we can traverse doubly linked list in reverse. To traverse doubly linked list in reverse, first we need the address of the tail node. To get the address of the tail node, again we use the while loop to traverse to the last node of the linked list and we store the address of the last node in the current node pointer. Now we have the address of the tail node in the current node pointer. So again, we use the while loop to traverse through the linked list in reverse. Now when we are traversing through the linked list in reverse, each time we reach a node, we print out the data stored in that node and then we assign the address of the previous node back to the current node. This means that we have moved one node backwards in the linked list. This loop runs until current node is equals to null. So when we reach the head node, the address stored in the head node is printed and the address of the previous node stored in the head node, that is null, is assigned to the current node. So this condition returns false this time and the loop terminates here. So this is how we will traverse the doubly linked list in reverse direction. Now let's run this program. Let's enter 7 elements in the linked list. So our program prints out the linked list in forward as well as reverse direction. Now remember one thing, we are printing the linked list in reverse direction. We have not actually reversed our linked list. Now we can also write this program in C++ using classes. So here we have declared the node class. The rest of the program is quite similar to the program which we have written in C using structures. The only key difference is in the syntax, which is explained in the last video. So we can run this program also. Let's enter 15 elements this time. So this program also prints out the linked list in forward as well as the reverse direction. As always, you can find the source code to these programs on our GitHub profile. Link is provided in the description box. So that's all for this video. In the next video, we will learn how we can implement circular linked list in C and C++. Thank you for watching this video. If you liked this video and found it helpful, do give it a thumbs up and subscribe to our channel for similar content. If you have any doubts or suggestions for us, feel free to share with us in the comment section. You can also reach out to us using our Instagram and Twitter profile. Link is given in the description box.